Okay, here we are in section 8.1, and this is on Markov processes, Markov chains, and we're talking about transition matrices. And we've got this transition matrix in problem number 2. And here's the question: determine whether or not it is stochastic. So a stochastic matrix is one in which the elements are all between 0 and 1. Now each one of these is between 0 and 1, inclusive, and in which the columns add to 1. Now, in this textbook, they're working with columns adding to 1. Some textbooks, it may be that the rows have to add up to 1. But in our book, we're using the columns adding to 1. So we have both conditions satisfied. All the elements are between 0 and 1, and the columns add up to 1. So we are going to conclude that this matrix is indeed stochastic. Problem number 4 asks us the same thing for this 3 by 3 matrix. Is it or is it not stochastic? Let's look at each condition here. So as I look through this matrix, I see that all the elements here are between 0 and 1 inclusive. Everything's between 0 and 1, so that condition holds. And then when I add these, here's a 0.7, here's a 1. Here is a 9, 10, 11. That's 1.1, right? So when we add down here, when we add down this column, we get 1.1, which is greater than 1. So this matrix here is not stochastic. See if I can spell that. Now in problem number 8, we're given this transition diagram and asked to convert this to a transition matrix. So why don't we do this by selecting a letter to name our matrix. How about T? And we have two states. I'll name them here, A and B. A and B. I'll write in my square brackets for the matrix. And we notice here that going from A to A is 2/5, right? So that's going to go from A to A. Now the way we're doing this is we're going from column to row. So we're going, here's how we're doing this. We're going current to next. So A to A, as we go from A to A, that is 2/5. So we can write a 2/5 here. Now it is stochastic, so it should be that A to B, right? A to B should be 3/5, because these have to add to 1. So let's check that. A to B, sure enough, is 3/5. So let's put our 3/5 in here. And then going from B to A, well, we can see it here. B over to A, this is 1/4. And then we can see that B to B, right? B back to B is 3/4. And this is stochastic. Every element is between 0 and 1, and the columns add up to 1. And there's our transition matrix.